And two, let's talk about the how we can protect the bearer tokens at the authorization server. So if an attacker is able to gain access to the authorization server database or launch a SQL injection against it, then the security of the multiple resource owner might be compromised. True, because the place where the token generated, it is somehow the attacker gain access or just put some injection, then yeah, it just be a security concern for all the resources, right? Who are using that token or just allowing the token, allowing this client to use that token. This happens because the authorization server is a central point that coordinates and emits access tokens issued to multiple clients and potentially consumed by multiple protected resources. In most implementations, the authorization server stores access token in a database. In general, what we see in our case also, right? In current in my lab, maybe you have seen that we are storing the token where in the internal database of Ping Federate, that is HSQLDB. But yeah, when you are going for a industry, you need to use some external database, right? Like maybe Oracle or yeah, Ping directory if you are using. So Ping directory can also able to handle that. The protected resource validates them upon receipt from a client. This can be achieved in multiple ways, but typically a query is launched against the data looking for the matching token. As one efficient precaution, the authorization server can store hashes of the access token. For example, using SAR-256 instead of the text of the token itself. In this case, even if the attacker was able to steal the entire database containing all access token, there is not much it can do with the information leaked. Right? So again, we are trying to minimize. So if some way, like if our database is compromised, but the data what attacker is getting, it will not able to do much thing, right? Because we have the hash, we just hash that token and kept in our database. It's not kept at the token form. It's not kept at the text form, right? We have the hash. We store in the hashes of the access token using some standard algorithm, right? Which is tough to decode. So again, we are trying to minimize it. Although hash salting is recommended for storage of user passwords, it should not be required to use additional salt because the access token value should already include a reasonable level of entropy in order to make offline dictionary attacks difficult. For instance, with the random value token, the token value should be at least 128 bits long and constructed using a cryptographically strong random or pseudo random number sequence. In addition, it would be good to keep access token lifetime short in order to minimize the risk associated with the leak of a single access token. This way, even if a token is compromised, its valid lifetime limits its usefulness to the attacker. If a client needs to have a longer access to the resource, the authorization server can issue a refresh token to the client. So again, you see in the industry also. So again, we're trying to minimize the risk. If somehow the token is leaked, we have the validity of the token is only 1 hour or maybe 30 minutes like that, right? So in that case, like the attacker or someone is not able to use further the token because yeah, that is going to expire very soon. And by just implementing this solution, you maybe your application can complain, hey, if you're just giving me 30 minutes lifetime of the access token, how I can just maybe my user will complain, right, that my session is getting out. So for that, you have the refresh token concept, right? So once your access token is getting expired, you can just call, before that you can call your refresh token, and using that refresh token you can renew your access token, and again it is valid for some time, right? Let's say 30 minutes like that. So in that case, the session will still exist and user will not see any problem while just working on some application or other OIDC based application, right? So that's the concept of refresh token, right? So you can just minimize the access token lifetime and just introduce the refresh token part. Refresh tokens are passed between the client and the authorization server, but never the protected resource, limiting the attack surface for this style. Because yeah, the refresh token we are not passing to the protected resource, right? So limiting the attack surface for this style of long-lived token significantly. The definition of what constitutes a short token lifetime depends entirely on the application being protected, but ideally the token should not live much longer than it will be needed for an average use of an API. Ultimately, one of the best things that can be done at the authorization server is pervasive and secure auditing and logging. That means when a token is issued, consumed or revoked, the context in which that took place, that is a client, resource, owner, scopes, resource times and so on, can be used to watch for suspicious behavior. As a corollary, all of these logs must be kept clear of the access token values to keep them from leaking. This means that the logs should not include access token because they are sensitive and could be exposed if they are recorded. Keeping them out of the logs helps protect them from being accidentally shared or leaked. That means again we are talking about the final thing about the minimizing the vulnerability. That means you have implemented all your solutions, right? You just reduce the lifetime of the token. You just introduce refresh token. You are storing the access token in your database by hashing that, not in the plain text. So all these things you kept, but after that also, and also like yeah, you are not what I can say, you are not putting the data the access token value in your logs also, because somehow it can be also security risk, right? If somehow it can be exposed the logs part, yeah, anyone can just get an access of just steal that an access token, steal that access token, sorry. Yeah. So after putting all this solution at the authorization server, like lifetime, refresh token, storing the token in the hash form using the standard algorithm and putting instead of the plain text, and then just not putting the token in the logs. After all these solutions, you need to monitor your behavior, right, on a 24 by 7. Like for example, like if there is any transaction coming, right, the the authorization server, right, the design, the way you are designing your server, the authorization server part, you need to just see that you just need to understand the behavior of that request, so that you can just take some precautionary, right, before it can be become a major issue. So that's why the monitoring, it's 24 by in the industry also see you that in the industry also you see that we have multiple monitoring tools which are continuously monitoring the behavior. If we see any difference in general, we need to raise a flag, we need to go and investigate that. And there are automations also in that. So in sometimes if it just see that, if let's say talk about the authorization code only, right, so if authorization code is just used for once, right, but at the same time if it tries to used again the next time, in some cases the authorization server, what authorization server will do, authorization server will simply revoke the access token issued for that authorization code, right? So yeah, it can just try to mitigate again the rest. So that's the part of monitoring, automation and all we need to do after putting all the solution in that case also. So you just need to design the solution in this way, and then also just try to monitor the behavior of the client, resource owner and everything, right? Time, from all those you need to just build, you just need to write a program which can just do all those things, right? Okay, so this is about this is most important thing for the authorization server part, because that is a critical thing, right, where the token is generated and stored. And also that client also, because we are passing this to client, so client also needs to handle it carefully. And also client is delegating that to the protected resource. So now we need to see that how we can make the bearer token secure at the resource server side, at the protected resource side. So we just talked right now at the authorization server. Before that we talked about at the client side, and now let's talk about the protected resource. Okay, if you have any question, please put in the comment section. Let's jump to the next one. Thank you.